lecture series on advanced separation process. Myself, Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. In this lecture, we'll discuss about selection criteria for membrane module and membrane material such as rubber polymer, glassy polymer, ion exchange polymer, and inorganic membrane material. So let us first discuss about selection criteria for membrane module. As discussed in a previous session, we know that there are mainly four types of membrane module. First, which is a split and frame membrane module. Second, which is a tubular membrane module. Third one, which is a spiral wound membrane module. And fourth, which is a hollow fiber membrane module. So this one is a split and frame membrane module in which feed is enter from this side, a molecule which is smaller than pore size of membrane that can be passed through the membrane and that can be collected from this side. A molecule which is larger than pore size of membrane that can be rejected by the membrane and that will be collected from this side. So we can collect rejection from this path. Then also discuss about the tubular module in which tube are used as a membrane tube wall made of the membrane and support layer in which the feed is passed from this tube side and permeate will be get from the passing through the wall of the tube which is a membrane, and we can collect the permeate from the cell side and we can get the retentant or rejected from the tube side. A tubular module mostly acts as a cell and tube heat exchanger or look like cell and tube heat exchanger in which tube acts as a membrane material. Then discuss about spiral wound membrane module. In spiral wound membrane module, permeate pipe provided center of the all membrane which roll over the permeate pipe, and the spacer is provided to pass the feed. So in spiral wound membrane module, permeate that can be collected from this side or transferred to the collection pipe and rejected or retentant can pass through the membrane. Then discuss about hollow fiber membrane module. Hollow fiber membrane module which also look like a tubular membrane module, or the principle of separation of hollow fiber membrane module is the same as the tubular module, but the difference between the tubular module and hollow fiber module is that in tubular module we are going to use the tube which diameter is near about the 0.5 centimeter to the 10 centimeter, where in hollow fiber membrane module we are going to use the fiber or can say that filament which diameter is in micron. So there are the number of fiber or can say that more than 1000 fibers are used in one cartridge, and number of cartridge are used as a module in the hollow fiber membrane module. So let's discuss about the various selection criteria for this all type of membrane module. For range of pH tolerance in reverse osmosis, plate and frame membrane module can be used up to the 4 pH to 7 pH. Similarly, spiral wound membrane is also used as a 4 pH to 7 pH. In tubular membrane module is also used as a 4 pH to 7 pH, where hollow fiber membrane module pH range is higher comparatively the plate and frame membrane module, spiral wound membrane module and tubular membrane module. Hollow fiber membrane module can be used as a 4 pH to 10 pH. Resistance to mechanical damage is a good in plate and frame membrane module compared to the tubular module. So if we are going to point of view of the resistance to mechanical damage, plate and frame, spiral wound and hollow fiber membrane module gives better result compared to the tubular module. If we are going to in point of view of the resistance to fouling, the tubular module gives very good result compared to the plate and frame module and spiral wound module and hollow fiber module. Hollow fiber module gives a very poor result in term of the resistance to the fouling, where plate and frame and spiral wound module give moderate and good result respectively. Then if we are going to talk about the packing density, Packing density in plate and frame membrane module is 30 to 500 meter square per meter cube, where in spiral wound the packing density is 200 to 800 meter square per meter cube, where in tubular module packing density is 30 to 200 meter square per meter cube, and for the hollow fiber 500 to 9000 meter square per meter cube. Power consumptions in a plate and frame membrane module is which result in good efficiency compared to the tubular module. Tubular module give very low power efficiency compared to the plate and frame, spiral wound and hollow fiber membrane module. Major application of plate and frame membrane module is in dialysis, reverse osmosis, pervaporation, ultrafiltration and microfiltration, where spiral wound membrane module mostly used in dialysis, reverse osmosis, gas separation processes or gas purification, ultrafiltration and in microfiltration, wherein tubular module has a limited application in a reverse osmosis and ultrafiltration. And hollow fiber membrane module mostly used for the dialysis and gas separation, but it can be also used in limited application of reverse osmosis and ultrafiltration. It gives better result in dialysis and gas separation processes. So this is all about the various selection criteria for membrane module. Now let's discuss about various types of membrane material. There are large variety of membrane polymers which are extremely used for the preparation of membrane. They may be classified as a biological membrane and synthetic membrane. We know that biological membrane which contain in human body or any living organism such as a cell membrane, where in synthetic membrane there are mainly two types of membrane: polymeric membrane and inorganic membrane, or hybrid membrane which also known as a ion exchange membrane. So organic membrane classify as a glassy polymer, rubbery polymer, where inorganic membrane further classify as a ceramic membrane, glass membrane, metal membrane and zeolite membrane. So if we are going to classify in normal basis of this membrane material, then that can be given by rubbery polymer, glassy polymer and ion exchange polymer membrane. So let's first discuss about the rubbery polymer. When the polymer operates at temperature above the glass transist temperature is called rubbery polymer. So what is meaning of glass transist temperature? The glass transist temperature is a temperature range where the polymer substrate change from rigid glassy material to a soft material and is usually measured in terms of stiffness or module. So from this graph we can see that this is a glass transist temperature. If we are going to increase the temperature in this direction, we are getting the rubbery state. So if we are going to the reduce the temperature, we are going to a glassy state, and this state is between glassy state and rubbery state, which known as a glass transist temperature. So we can say that temperature below the glass transist temperature, that is state of glassy state of material, and above the temperature, or can say that above temperature of glass transist temperature is known as a rubbery polymer. If we are going to increase further more temperature, then rubbery flow of materials occurs, and it converts into the viscous flow. So there are various examples of rubbery polymers such as a silicon rubber, polydimethyl siloxane and polyvinyl ammonium thiocyanate. The behavior of rubbery polymer is essentially that of viscous liquid. In rubbery polymer, segmental motion of the polymeric molecule are rapid like liquid molecule. These polymers have a high flux of organics and low flux of water. So this is all about the rubbery polymer. Now let us discuss about the glassy polymer. When the polymer operates at temperature lower than transist temperature or glass transist temperature is known as a glassy polymer, which state is shown in this figure here. So if we are going to reduce the temperature below the glass transist temperature, we are getting the glassy state. So when the polymer operates at temperature lower than glass transist temperature is known as the glassy polymer. These polymers are crystalline. Segmental motion or rotational of polymeric molecule is a restricted, leading to heterogeneous of polymer structure. Polycarbonate, cellulose acetate, polysulfone are example of glassy polymer. So this is all about the glassy polymer membrane material. Now let us discuss about ion exchange membrane material. Ion exchange membrane are essentially ion exchange resin made in membrane form. These are having ionic charge on polymeric segment. A negative charge membrane is permeable only the cation. So this one is a cation exchange membrane that can only pass the cation or positive charge ion, and that can reject a negative charge ion such as this Cl minus. So cation exchange membrane is a negative charge ion and that can only pass the positive ions and reject the negative ions. Positive ions, which means cations. That's why this type of membrane is known as a cation exchange membrane. Where or similar, when the membrane is a positive charge, it is permeable to anion and is called anionic membrane. Ion exchange membrane are very selective for the water. In anion exchange membrane, a charge of membrane is a positive. That's why that can only pass the negative charge ion or anion, and that can reject a positive charge ion, which is known as a cation. So this membrane can only pass negative ion or can say that anion. That's why this type of membrane is known as a anionic membrane. So this is all about today's lecture. I am completing my lecture here. Thank you.